Hello, everyone, and we are live. A bit late, but it's okay, totally fine because we are going to explore something. So, if you are ready, let's do that. And we are live also on LinkedIn. And as you might know, that I am now moving my, like you can say, content more on Rust language than any other thing. So you will see for few, like, other, so for few weeks or months, I can say I will be on Rust, creating content about Rust and learning it and sharing all my knowledge with all of you. So I'm not an expert, or I will say, like, I'm a beginner to Rust. I'm not having any expertise. I have never built anything with Rust. So this is what I want to share with you. But since I am learning, so I thought it would be good if I learn along with you guys. So what my strategy is simple: learn something, get really amazing knowledge, get deep knowledge of it, create video and share with all of you. So if you are following me on my YouTube channel, that means Bitfumes, you might know that yes, I am sharing content on Rust nowadays. So like yesterday 2 videos, now 2 videos, so total of 4 videos I have shared, and today also I will share two more. And that's because I think today is going to be next to. So that's because I started learning. So once I learn any concept in Rust, I start sharing it with all of you, and soon we will also explore more of the things. But today I thought it's really amazing to understand and read out, I can say, whatever is this ownership thing in the Rust language. So I'll share the Rust documentation. So this is the documentation of Rust. Basically, what you do, you just search Rust lang, go to rust-lang.org. In this website, if you click on this learn section, then there is a read the book. So this book is having this understanding the ownership concept. Now this concept is really, really important if you want to dive into Rust. And this is really, I can say, important plus tough thing. So, what is ownership in Rust? So, ownership in Rust. Let's read out, and then I'll try to explain things whatever I get. And if you know anything, just let me know so that I can also, you can say, understand things from your point of view. So, ownership in Rust's most unique feature, obviously, it's the unique feature, has deep implications for the rest of the language. It enables Rust to make memory safe. We all know that Rust is a memory safe language. That's why Rust is so popular, and it's a system language. That means it's more of low level language where the code is very close to the system, and that's why it called system level language. And so it's important to understand how ownership works, and this chapter is going to let us. So what is ownership? Ownership is a set of rules governed by Rust to make it memory management. Hmm. Yes. Now there are three different kind of, you can say, uh, memory management thing. One is all program have managed a way to computer memory while running. Okay, so जब भी I'm switching to Hindi. That's not good. So whenever we need to run any program, uh, we need to manage the memory in our Rust or any programming language. So some programming language has the garbage collection, so that's really important because what is garbage collection? So if you are using if you're creating a variable and then you do something with that variable, and after some time you're not using that, but still that variable exists, and whenever you need it you can use it. That's a simple thing. But what if you are never going to use it? Isn't it a memory waste of memory? So garbage collector will see for any wastage of memory and then clean it. So it's like that regularly looks for no longer used memory as a program run. So whenever the program run, it looks into the, hey, this variable is not used, so we can just remove it, and that's how garbage collection is good. So that's really nice. But in other language, there is a program must explicitly allocate the and free up the memory. Just like in the C, you need to define that, hey, here's I'm starting the variable and here is we don't want that variable. So that's a developer's job who is writing the code. That's a programmer's job, I can say. So it's really good if we have a garbage collection. So garbage collection is automatic, this one is manual. Now, what is the problem with garbage collection and why Rust uses the third approach, which is called memory management by ownership? What is this ownership concept which Rust uses and why this garbage collection is bad? So, see, what happened is when you are using the garbage collection, so since garbage collections will look into your program while the program runs, at that time you need the garbage collection, you need the garbage collector. So the program has to be shipped with the code, so that is making your code heavy in, I can say, not smaller in size, big size. So that's a problem with the garbage collection. And also, if what if the language itself can do something which prevent you to write any unsafe, you can say, um, a better memory managed program? What if the language itself forces you to write a memory managed program? In that case, the concept of ownership comes here, because ownership is a new concept for programmer. It needed to be really, you can say, in the concept of, in the mind of programmers, you need to understand it properly. But before going into the ownership, we first need to understand what is heap and what is stack. So if you are coming from other background of I think I have one comment, so let me just read that comment. So Rivash is saying, starting Rush. What is the use for Rush? By the way, this is Rust, not the Rush, and this is a system language, and which is extremely, extremely popular nowadays. You can consider it like a new age C, C++. So that's the power of this Rust language, and since Rust is memory safe and really nice language to write, it's popular for creating many things. So see, uh, Rust can combine with WebAssembly to create something which you can run directly on the browser, which uses the GPU, the CPU of your of client's you can say system. Not you need that thing on the server. So that's a great thing. Maybe example, you can say Figma is written in WASM or WebAssembly. So you can combine that Rust with WebAssembly to create something like that. You can create the game, heavy games on the browser with the help of this kind of languages. Okay, so that's the thing, Rivash. So I hope you understand it. Let's move forward. So stack and heap. Many programming language doesn't require you to think about stack and heap, but since we are in Rust, we need to understand. Both stack and heap are the part of memory available to your code at the runtime. So whenever you run your code and you have a variable, so that variable can be using any memory in two ways. One is with the stack thing, second is the heap thing. So let's understand about the stack. Stack stores value in order to get them and remove value in opposite side, which is last in but first out. So think about like a stack of plate. So you have one plate, then you have second plate, and your third plate. Now, if you need to remove the plate, you always remove from the last, okay, and then the third one and the fourth one, and continue like that. So last in, so from the top it's in, and the first is out. Think of the stack as a plate. When you add more, you put on the top of the pile, but when you need, you take it from you take off the top. I think you put on the top, and okay, so that's the thing, like always add on the top and remove also from the top. That's the thing. So when you need plate, you take off the top. So adding from the top and removing also from the top, no bottom thing. So adding and removing plate in the middle or bottom was not work well, because when you remove a plate from the middle, the whole stack will just broke down. Now, adding data is called pushing into the stack. This is good. This is nice. We are pushing it, and removing is popping. So push and pop. That's the thing we always want to have. Okay, that's good. So we understand that what is a stack and what is pushing and what is popping. So all data stored on the stack must have known and fixed size. This is really important. So when you use the stack, when you have the stack of memory, at the time whenever your data is having a fixed size. Now when you have a fixed size, suppose you create a number, then number always has a fixed size. You create a boolean always has a fixed size. You create a normal string. I'm saying normal string because there is a different kind of string in Rust. So whenever you create a string literal, I can say, is a fixed size. So data with the unknown size at the compile time or size that might change must store on a heap. So you only put the data on the stack if you know the size. So take the example of that plate. So we have a plate and another plate, another plate, another plate, but you can only put the plate above on the stack if you know that size. If it is too small or too big, it doesn't fit into the stack. That's the problem. So in that case, we are going to use a heap. What is heap? Heap is less organized. So when you put the data on a heap, you require a certain amount of space. Now, obviously, the memory need to be allocated. So memory allocation find empty spot on the heap that is big enough. So if you are creating some variable data, it will try to allocate or try to fix some part in the heap. So consider a heap as a portion of memory, and in that memory it will first look into where is the empty spot. If there is an empty spot, then it will say, okay, I need x amount of memory, and it just allocated. It just say that, okay, this is I will need, I don't know what it should be, so it will be small or it will be larger, but I need big enough so that it can put all the data into this. Okay, so that's the thing, that's the only thing. Marks it as being in use and return the pointer. So when you add something into the heap, the memory allocator, the system in the Rust which allocate the memory, find an empty spot and then return a pointer. Now what is the pointer? Pointer is actually the address of that location. Now, address of that location means the memory address of that location, which is really important. This process is called allocating on the heap and is sometimes abbreviated as allocating, just as allocating, nothing else. Because pointer on the heap is a known fixed size, because I told you when memory allocator need memory, so it will find an empty spot in a heap which is big enough to mark the data on that. So that's why the pointer on the heap, the memory address, is always fixed size. You can store the pointer on the stack. But when you want the actual data, you must follow the pointer. So what if we are doing? We are having the data somewhere else. Then we have an address of that data, and then that address is putting on the stack. Now, what if we have a heap and we have a stack? When we put normal data into stack, obviously the data is on that stack, no worries. But when you have heap, then instead of data we have the pointer on the stack, and that pointer is having the address where the real data is. So which is having a more work? Obviously heap is more work. The language need to do more work to get data from the heap. Think of being seated at a restaurant. When you enter, you state that number of people in the group. The host find an empty table, obviously, and that fits everyone and lead you there. Now, if someone in the group comes late, then the host can just ask where. Then the guest can ask where you have been seated, which is the address. So basically, you are having some data. Now you want to add more data on that. So first you need the address of that thing where the data is allocated. So you get the pointer from the stack. Pointer is actually the address. Then you go on the address and then add the data or remove the data or whatever you want to do. But it's really more work to do. So it's given there. Pushing to the stack is faster than allocating on the heap. Yes, we know, because the allocation never has to search for place to store new data. That's the point. And the location is always on the top. So when Rust try to add on the stack, then it doesn't need to find any data. It's just like, okay, I need to add something on the stack. It's always on the top. But what happened on the heap? Allocating space on the heap require more work, because first the memory allocator must find a big space, big enough space to hold the data, and then it perform the bookkeeping. That means setting there and getting the address, then putting that pointer into the stack. Lot of work is there. Okay, so that's the point. Okay, now accessing data in the heap is slower than accessing data on the stack, because you have to follow a pointer to get there. Contemporary processors are faster, so processor can do that, but that's not a good thing, because we want a faster program which we can get through our our Rust kind of programming language where we can have that. So this is the basic concept of stack and heap. Stack is faster, heap is slower. Now comes the rule of ownership in Rust. So before that, there are two paragraphs. Let's just read it quickly. When your code calls a function, the value passes into the function, and the function's local variable get pushed into the stack. Okay, so when the function is over, then those value get popped out of the stack. So that's the power of a stack. When you use something, great. When you don't use it, it just remove it. Keeping a stack of what part of code are using what data on heap, minimizing the amount of duplicate data on the heap. That's great. So cleaning up the unused data on the heap so you don't run out of space. So to add something means any variable data on the heap, you need to find a big enough space. But what if you don't have the space? So that's the point. We always need to clean up the unused data on the heap so you don't always run out of space are the all problems that ownership solves. Now, so we have the problem like, what if we don't have anything on the heap? Then how do we add or find big enough space? Then comes the ownership rule, which says that each value in Rust has an ownership. Okay, each value in Rust has an ownership. So whatever you create has to has a owner. There can only be one owner at a time. So that means, what is the owner and what is the one at a time means? Suppose you created a name variable and you put Sarthak inside it. Now that string is having owner of name as a variable. Now you created a username and you put the value of name inside the username. So username is equal to name. Now the same thing is having two ownership. This is not allowed in the Rust. So Rust is that if that string Sarthak is only always available in name variable, then it should not be available in any other variable if that's the same exact string. Okay, so that's the point. It says that there can only be one owner at a time. When the owner get out of scope, the value will be dropped. Okay, what this means? So name is Sarthak, then we created username is equal to name. Now the value of name is now transferred into the username variable. In that case, the value of name is redundant because the exact same value is now available in the username. So what ownership rule says that you need to drop the name variable. Name is out of scope now because you don't need that. Exact same data is available in the username, so why you want that? So ownership of the string Sarthak is now shift from variable name to variable username. This is what we are doing. So let's understand it from the example. It's variable scope. So in Rust you can create a scope by using these curly braces even inside the you can say on the main function. So I can just show you. So remove everything and I say, if I want to create a variable, say let x is equal to hello. Now x is only available in the, I think I need to share something. Okay, so here we have created this and s is hello. Okay, and now once this braces closes, that means the s will be out of scope. That means if we try to access s out of this scope, then s will not be available. This scope is now over and s is no longer valid. Okay, so can we run it? I think yes, we can run it. No output because we are not doing anything. Can we change something? Oh, that's actually inside the function it's showing. Anyways, so what is a string type now? So in Rust, you can define strings in two ways. One is string literals, which we did here. So this is string literal, hard-coded string. And second is using string type and say colon colon from function. And then we convert this hard-coded string to a string. String means the string with the type of this string, not the type of str. Okay, so this is what we did. Now, what is the benefit of using string from? Now, this we can change. We can change. Remember one thing, we said that if we can have variable things, that means anything which we can add and remove later on while compiling or while the program is running, that comes into the heap. And this is always going to be the fixed thing. We cannot add and remove anything into this hello. We cannot do that, and this means this is going to be into the stack. So this part will be stack super fast. But this one is not a stack. This one goes into the heap. Now, since this one goes into the heap, this can create problem. This can fill up the memory of the heap, and we can run out of the memories. So, how do we solve this thing? So, we can solve by memory and allocation thing. So, first of all, see, whenever you define something, when you get out of the scope, then that thing, that variable get, you can say, get uh, dropped. I can say dropped. Yeah. So the Rust will call a function called drop, which just drop this variable s and invalidate this. The purpose of this is really nice. Purpose is like if we are having this hello in s1, we move this s1 into the s2, then after this s1 is no longer available, because at this time, see, because at this time, when we are transferring value of S1 to S2, both are pointing to the same memory allocation. And if from the concept of invalidating or dropping, if we are dropping S1 and S2 both, then that could be a race condition. That could be, that could lead to a problem, or what we call, maybe given there, double free error. So when we are freeing up the memory for S1 and S2, both are pointing to the same same memory position. That means S1 is pointing, let's say, X, and S2 is also pointing X. And when we are dropping X, and then when we try to drop X for S2, we say that, hey, there is no X available because X was dropped already when we are dropping for S1. So that was the problem, and that's called double free error. Now, how to solve this? Rust says that, hey, I am going to invalidate this S1 once you transfer the ownership of the value from S1 to S2. Okay, so um, this is like once you transfer the ownership from S1 to S2, S1 become invalidated. So we can say that data is moved from S1 to S2. That's why it's known as moving of the data. It's not copy, it's not deep copy, shallow copy. What is shallow copy? Copying just the pointer. Deep copy means copying everything. So we are not doing any copy. We are doing move. So move is the thing. Now, how do we say that this is really powerful? By the way, when you really want to copy things, you just say dot clone. Now this is really important. When you really want to um, copy something and do not want to invalidate s1, then you say dot clone. So clone will keep the s1 and will also create a new variable called s2 with the same data, okay. At that point, you can use both s1 and s2. But when you're not doing this, when you are not cloning, when you're moving just data, then if you try to use s1, you get error which says that, hey, value moved from here, nothing is there, what should I print? That's the thing. Okay, so that's powerful. And now we have some, that Nang says borrow checker. Yeah, we can call borrow checker. Great. Okay, next let's move forward and say stack only data copy. So everything is fine here. So what if we say something like x is equal to 5, we move the value of x to y, and we are trying to print x and y. So from the previous experience, we say that, okay, this is going to raise an error because now the value of x is moved to y. But that's not the case. That's not the case because remember, this is integer. Integer is fixed size. Fixed size goes to stack, not on the heap. And if something is on the stack, Rust says, I don't have any problem because it's on the stack. It's very light. It's really easy to add, easy to remove. I don't care. It's not creating any memory problem. Memory problem always occur when something goes into the heap, because in the heap you need to first find and allocate the uh, memory of big enough size, and then you add the data, then you return the pointer, and then you put the pointer into the stack. A lot of work to do. So in this case, whenever any variable is having a, you can say, stack only data, that's never going to be invalidated or never going to be dropped. So we call it, sorry, you don't have to call clone. It by default clone, and that's how this is really working. Now, ownership and function. So by the way, all these, uh, you can say, types are called stack data, stack data type maybe. So U32 boolean, float, character, I32 tuple with the same I32 but I32 with or number with a string. Now this is not going to be copied. It needed to be on the heap, and then heap, that means ownership will come. Now, ownership with function. So see here, first we create the s variable, and when we create the s variable, then s comes into the scope. Take the ownership. There is a function which just going to print it. Okay, and since we are passing it directly, the value of s moved to this other string, which comes into the scope through this function. That means as value moved into the function. Remember, this is a string. This is on the heap. When we transfer it, it just move the value into the function. That means s no longer exists. If we try to use s after take ownership, it will not be available. Okay, so that's the point. And that's not case with the x, because x is just integer, which is a stack data type, and in that case it always copy, not move. So x will move into the function, but since I32, it is actually copied, not really moved. So we can use x after this function also. Okay, now what about the return value and scope? So what we can do, we can have give ownership function. We create some string, we return that string. Now, once we return that string, this is going to be the invalidated. We get the string in the S1. Now we have another string on the S2. Take, give back to S2. So we create another. So since we are passing the value of S2 here, so it is moving. So S2 is moved into the function. That means S2 will not be available after this. And then S3 will be there always. Okay. What next? Here's the example of tuple. So you can use S1, and then you have this string. You are passing this here. That means you are moving the value of S1. So we are moving this S1 to this calculate length. Here it's accepting the string. So it's accepting that string. We are getting the length of the string, and then we are returning the string plus the length. That means a tuple of string and length, which we call it here. So everything is fine, no worries. But this is too much ceremony and a lot of work for a concept which is really common. We just want to get the length. Why we want to just pass and everything, move it here, and then reevaluate and get a new functions, a new variable s2 and length, a lot of things. So instead we can do something better, which is called referencing and borrowing. Now, instead of passing f1 directly, we can pass the s1 reference. What is reference? Reference means the pointer. So a reference is a pointer in that it's an address we can follow to access the data stored on the address. Basically, we are passing the address. Remember what happened on the heap? We find the big enough space, we put the data, and that pointer, the address to that memory location, we call it pointer, is stored on the stack. Now that pointer is passed here. So since we are passing the pointer, we need to accept the pointer here also by using the ampersand also on the type. Once we get that, then what we need to do, we just need to return the length, and everything is good because we have the pointer, we can do what we want, and then we get the length, everything is fine. We can use s1 because we are not moving it, we are just passing the reference. So ampersand references. So what the reference is? S1. See, S is the reference of S1. So S is having a pointer to the S1 pointer, which is pointing in memory location. So once this function is done, S is invalidated or S is dropped. So since S is just a pointer location, or can say that reference, we don't lose S1. So that's the point. Great. So this is how we understand the ownership and the things in Rust. I believe these are just theoretical things, but I will try to create a video where I graphically can explain more about Rust ownership concept, references, and all other things which we are having here. I really like how I'm starting to do these things, which is talking to you and directly doing whatever I am doing here and live streaming so that you can see how I learn things. I read each and every line and then come up with the concept. So thank you everyone for being here, and it was really short live so that I can start thinking about how Rust works on a memory level. So thank you everyone. And if you got any good information from this channel, just comment below on this channel or on the live section. And let me know if you really want to get dive deeper into the Rust and or maybe on the Golang. If that is the case, then I will create more content around it. You will make a Rust programming series on your YouTube channel. Hey, if you don't know, I already have that Rust programming series, and which I can show you. Just a minute, I'm going to share that playlist with you. So here's the playlist for Rust programming. Here's the Rust programming, Rust for beginner series. So check this out, and you're going to get videos as I create. So I generally try to create 2 videos per day, and because I need to learn it, I need to understand, create the concept, record it, edit it, and then publish. It's a lot of work to do as a beginner of Rust programming, but I try to create the content only once I get the concept. So that's why this concept of ownership was really tough. So I thought, let's come and see how I can understand it. If you guys also want to join, which you did, is really amazing. So if you need any help, just let me know in the comment section. Maybe on you can DM me on Twitter, on LinkedIn, on my newsletter. Yeah, newsletter. I always forgot like there's a newsletter. So by the way, if you want to join my newsletter, which is Bitfume's newsletter, where every Wednesday I share my newsletter with all of you. And let me see how much. How was the I can share with you guys. No, no, not this. I want to share something else. So let's share the Zoho campaign dashboard. So this is the campaign dashboard, and this is the era of Jugaad is here because I have a new channel called Code Jugaad, which is in Hindi, and you can see I have like 25% open rate, which is really awesome, really awesome, and only 3 unsubscribe and 1% click, unique click, I can say, which is really awesome. So if you guys want to join this, and you can see I have a lot of you can say, let me do for everyone. So see, I have a lot of newsletter already published, and if you go to bitfumes.com/newsletter, you will find all these already published newsletter editions here. So we are having till 5. We will add more as soon as we complete this. So that's the thing. I believe if you have not subscribed to Bitfumes newsletter, go and subscribe, and we will meet on some other YouTube live, and don't miss out the Rust tutorials on like today evening 7 p.m. IST Indian Standard Time. You can convert 7 p.m. IST to your time wherever you are. So that's really nice. So goodbye, good night, wherever you are. See you on the next live.